Here we have a cone-shaped paper cup and water is leaking out of it at a rate of 2 inches cubed per minute. Cube, that's volume. That is volume, a change in the volume. The cone has a diameter of 8 inches and it is 6 inches deep. That's the entire cone. How fast is the water level dropping when the water is 3 inches deep? That's a related rates problem. Let's do the basic outline. Step 1, we're going to outline the given information. The two quantities that are given are the volume as a function of time and the height of the cone as a function of time, or the height of the water in the cone. The rate that's given to us of one of those quantities, dV dt, is equal to negative 2 inches cubed per minute. It's negative because the dripping water is leaving. It's decreasing the volume. And then the relationship between the two, I had to dig out this relationship. The relationship between the volume and the height is V equals pi r squared h over 3. Okay. Well, there's a problem here. V depends on too many variables. We only want it to depend on H, not R. So we're going to have to work on that. That's going to take a little bit of trouble. The diameter of this cone was 8, what were they, inches? Yes. And that implies the radius on the top of the cone is 4 inches. Okay, there's a picture of our cone. There's the water level, the height. There's a little r here for the radius of the water. And then the total height is 6 inches of the cone. The height of just the water portion, that's what we're calling h. So that implies if we opened up these cones, the little one would give us this r compared to h, and the big one corresponds to 4 compared to 6. So this is a similarity. We can set up a similarity equation. R over h equals 4 over 6. Solve it for r, we get 2h over 3. Great. So we were able to set up similar triangles for the cone of water and the entire paper cone to express r as a function of h. Now we're substituting it back into the volume relationship. V equals pi times r squared h over 3. Replace the r with 2h over 3. Simplify. You get 4 over 27 pi h cubed for the volume. Great. Now we have an equation relating only the two quantities that are given, the volume and the height. Okay. So V is equal to 4 over 27 pi h to the third power. Now we're going to find, they're going to ask us to find the derivative of h with respect to t. In other words, the rate of change of the height when h is 3 inches. Okay, so the water's leaking out. What is the height of the remaining water when h is 3 inches? What is the rate of change? So we're going to differentiate. dV dt equals 4 over 27 times pi times h, well, times 3 times h squared. Okay, hold on just a second. What are we doing here in step 2? We're taking dV dt. Oh, we're doing the derivative. dV dt on the left is equal to 4 over 27. Bring that out. Bring the pi out. Now take the derivative of h to the third power. It's power. Use the power rule. The third power comes out in the front times h to the second power because we subtracted 1. Then hit it with the chain rule, dh dt, because h is a function of t. That implies dv dt is equal to, simplify by canceling a factor of 3 on the top and bottom, we get 4/9 pi h squared times dh dt. Okay, that's our result. Let's go to step 3. We'll substitute into that result from step 2. The given dv dt is negative 2 and h is equal to 3. So that implies dv dt is negative 2 equals 4/9 times pi times h is 3, and raise that to the second power, times dh dt. The only unknown value is dh dt, and that's exactly what we're looking for. So isolate dh dt, it's equal to negative 1 over 2 pi. And that's the rate of change of the height. The units would be inches per minute. Perfect.